On this slide, we're going to start focusing more on your code and splitting it up into services and running inside the data center. An application, as the term we'll use, it consists of many services. And a lot of times today, people use the term microservices. If we look at this slide here, this is a cluster, if you will, or a data center. Let's call it a big box a data center. And it is running an e-commerce application that, let's say, you have written. But you have divided your e-commerce application into 3 services or microservices, if you want to use that term. There's a website service, and there's an inventory service, and then there's an order or order-taking service. Now, this could be a single cluster that has all these different services running in it, and we have the website service running on, let's say, 3 virtual machines, inventory on 2 virtual machines, and orders on 4 virtual machines. So it could be a cluster of 7, 8, 9 VMs running in here. Or you could decide to deploy it where the web service is in one cluster, the inventory service is its own cluster, the order service is its own cluster. And a cluster is a single unit of management, and it's a single unit of networking. So a lot of times it's more convenient to set this up as a single cluster, but maybe you do want to set it up as different clusters because you want to separate the networking, you want to isolate these clusters from one another, right? Those are things that you'll have to consider. But let's talk about the individual services. Again, in this cloud world where we assume failure is always possible, you can't ever run one instance of your service because if it goes down, then clients that are trying to talk to it won't be able to talk to anything. So in this example, I've taken the website service and I'm running it on 3 different virtual machines. Those 3 machines are behind this load balancer here. And so when client requests come in, they hit the load balancer, and the load balancer picks one of those 3 machines effectively at random to go and send the request to. Now, these machines might want to go and talk to the inventory service, and there's numerous ways that can happen, and I will talk about some of those ways when we get to messaging communication and networking communication a little bit later. But very briefly, one option is we could put a load balancer in front of inventory, and we could put a load balancer in front of orders. There's other ways of using DNS to set it up or talking to specific instances, so you could do direct network communication. Again, we'll talk about that later, how we can communicate. Each service tends to have its own data store. This is definitely true in the microservices world by definition. By definition, a microservice is a service that has its own data store, and only that code talks to that data store. No other service would use the same data store. And the reason for this is because you don't want to have 2 different services dependent on a single schema. If one service wants to change that schema for one reason, you would now be breaking the other service. So you lose an isolation boundary there. So by definition, when we use the term microservices, it means that each service is using its own isolated data store. It owns it. It owns the schema. It owns which database technology are using a SQL store or a NoSQL store, and which one of those. Is it Cassandra? Is it SQL Server? Is it something else? It owns that entirely, and so if you want to change the way that microservice works, you can, and it should have no effect on any other microservice running inside your application. So that's what I mentioned here at the bottom, is that each service solves a domain-specific problem and has exclusive access to its own data store. So that's kind of the way you set this up.